In Module 8 this week, we will start to talk about Chapter 6 functions. So we only have one lecture this week because Monday is your midterm exam. So let's start introduce what are functions. We will talk about how to define and calling a functions and what are function prototypes. You will see how to send the data into the function and return the value. So that's what we will cover for this week. So why we need to have a function? So that's what we call the modular programming. You're breaking a program up into smaller manageable function or module. Because so far, we start processing more data and the user input like we have in the event-driven programming. Did you remember we give you the user menu to have the user to choose you want to calculate radius, rectangle, or square area. But actually, you see, we including display a big code in the program in the main function. So sometimes if we want to see where the program is wrong, it's kind of we need to start from line 1 to the end. So that's why we want to separate our program into different parts. So that's what we call the modular programming. So we have many different ways, but here we will talk about the first way is we will make that as a function. So the function actually is a collection of the statements to perform a task. And also you will use that all the time. For example, sometimes I want you to find the sum from 1 to 10. So now you know how to do that, right? So you can just write a for loop from I equal to 0, I less than equal to 10. So then you find the sum. But then I want you to find the sum from 100 to 200. Then you need to write another for loop for I equal to 100, I less than equal to 200. So actually those repeated code, if we perform the same task, then we can write the function. Because you can see just the beginning and the end, the value different, but you only need to get the sum. So that's why here we call that the function. Sometimes we want to perform a specific task, but just some value may be different. Then we're using exactly the same code. So instead, we have the repeated code. We can write a function. We just call the function and pass in the parameter. So in order to write a function or to motivate why we have the modular programming to help us to easy to debug and manage our program. So then we will actually use it to simplify the process of reading the program. We try to break down into the piece. So then we can have the big project. Because sometimes when you go to work, you have a big project, but then you really don't want to have everyone access the one source file, right? So then we can try to give everyone pieces of job. So then they can have their own code. And at the end, we group together. So that's in the future we call the modular program. But here that start how to make our task in the main function into multiple function. So here you can see if we don't try to break down our program, your main function in the future will be couple hundred line. So that's kind of difficult to know your task. But then sometimes maybe, for example, our task, we want to get a user input. We want to process user input. We want to display the output. So each one we can write different function. So for example, function 2 to get the user input, function 3 to process the data, function 4 to display the data. Then we only need to call the 3 functions in the main function. So that's much easier to manage our program. And then sometimes when you see your output is incorrect in the format, I know I just go to function 4 for output. So then maybe you see the output is formatted correctly, but data is incorrect. So maybe I need to go to see how I process data incorrectly. So now here, if we separate, divide into multiple functions in our program, we can easily to give the job to different people to write a function. And at the end, we're also easy to debug what's the problem. So that's the function. And actually, you already calling the function before. Remember, we show you the power function from the CMath library. You see, this one is a function called power. So the power function actually defined in the CMath library. So then you pass two values. The first one is the base. The second one is the exponent. So then when you call this function, we go to the CMath to looking for this function name. We pass in the parameter. So then they return us to the second power to the value. So this one is we call the function call. Once you define a function, you just call the function name within the passing argument. Then sometimes they will return the value or they just execute the function. But before you make a function call, you need to make sure you have the function declared and defined before that. So usually we call that the function definition. So the function definition is how I define the function to be called or to be used. So for example, in the CMath library, we will have a power function. So this power function, you see, they accept two arguments. So then we define two parameters. So each parameter data type is double. So then this parameter name in my function called base. So then the other one called exponent. So then when I call the function, I just passing the 5, passing the 2. So then base equal to 5, exponent equal to 2. So then we calculate. Then we will return a double value. So that's what we call the function definition. So of course, so far we don't know how this power function implements CMath. But you can think about how they do that. So from here, you see that's the function definition. So now we need to write a function definition. So let me go more detail about what is the function definition. A function definition including 4 important parts. The first one, we have return type. So return type is the data type of the value that will be returned from the function. So for example, you see here, the value from the power function return is double. So the return type will be the beginning. Then the second one is the function name. So the name of the function name follow the same rule as the variable. Also the name, like we say, the variable name cannot be keyword, cannot start with the number. Okay, so then all the rule is the same. So then we have the function name. Of course, the function name should be unique as well. Then afterward, you see we have parameter list. So this parameter list is we say the value after the function name in the parentheses. So inside the parentheses, that's our parameter list. You can have multiple parameter lists. You just separate with column. Each parameter list, you need to specify your data type and the parameter name. So then here you will see the parameter list actually is the variables contain values passed to the function. So most of the time, like we say, function, the purpose is you want to perform a specific task. The same task, but they may have different value. Like you see the power function. I can do the 5 to the second power. I can do 10 to the third power. They work similar. They just have the number multiply how many times. But one thing is they have the same algorithm, but different value. So those values will just pass in by the parameter. So you can specify as many as parameter you want. But every time after you define the parameter list, when you call the function, you need to pass in the value, follow the order. So that's the parameter. So here we have the return type, function name, parameter list. Then, right, that's your function body. Your function body will be the multiple statements that perform the function's task. They are in curly braces. So that's the function definition. We need to have all of them so we can call the function. Actually, you already wrote a function before. Actually, that's our main function. Our main function, actually the main is the function. So that's why before I told you I want you to use the int main. So you see you have the int return type, you have function name, you have the parentheses. Just so far we didn't have any parameter argument to pass. But sometimes I saw you guys using Xcode or other IDE, they did give you some parameter, but those parameters we didn't use yet. We may use that in the future. So then you see in your main function, you see what you want to do. And remember, I always told you guys, please return 0 after your function finish. So actually this one is already, you have your function definition. So the main function actually is the first function you already wrote many times. So that's our example for the main function. We have the return type is int. So then you see you need to return an integer at the end. So sometimes if we have function, we don't have any return value. If a function will return a value, the type of the value should be identical. So that's why you see int main will return 0 at the end. But sometimes if a function doesn't return a value, then we make this function we call the void function. So instead to give them any data type, we're just using the void keyword. For example, we just want to print something, we don't want to return anything. So we see here in the print heading, we just print one line. So this function, because I didn't expect them to return any value back, so we call that the void function. So after you have this void function defined, we can call them. So even here, you see we don't have any parameter list, but whenever you call a function, even you don't have parameter list, you need to call the function name with the parentheses. So then, for example, to call the function heading, print heading, so using the function name follow with the parentheses, that's very important. When called, program will execute the body of the code function. So after they terminate, so then execution resume into the calling function at the point they call. What does that mean? We see here. For example, we have example 1. Example 1, actually this one is earlier we said we have a void function. I want to display the hello message. So I just call this function is display message. So then you see we see out hello from the function display message. So after you have this function defined, remember if you want to call a function, the first thing, before you call the function, you need to define this function. So that's why now we have our function definition before that. Then in our main function, you see here, we print something from the main. Then we invoke this display message function. You call the function just using the function name. Don't forget the parentheses, even we don't have parameter list. Then after we call that, so we will come to line 10. Then we execute, we display hello from function display message. After we done, sometimes you can see people, even they didn't return anything, they will write a return here. But for the void function, you don't have to. But when they reach the end of the function body, they will come back to the next line where you call the function. So that's why earlier in line 19, we call the function, then we jump to line 10. So after we finish line 13, we come back to the next line after line 19. So that's why we print back in function main again. So don't forget, when I give you the example, you need to run from your IDE. Now here we download example 1 from we run on Cloud9. So then you will see you have your example 1. See here is our function definition. Then here is our main function. In the main function, we call display message. So that's why when you run, you will see the first beginning, they start running from the main. That's compiler by default. You see we display hello from main. Then we invoke line 19. So then they jump to the line 10. Then display hello from the function display message. So then after we finish, we go to the next line after the function code. So we display back in function main again. So that's our example 1. So then I have one peer exercise I want you to complete. So I want you to write a programmer info function to display your name and your ID. So from now on, you always need to call the programmer info in your main at the beginning. So how should you do that? We will have the answer in next